Guys, even though node application runs on single thread, that is main thread, there are some function calls inside standard library of node that will execute outside of that main thread using a concept called thread pool. To understand how this is working, to understand this concept, let's start from the basics. Okay guys, let me start with callback. In JavaScript, callback is a function that is passed to some other function which will be invoked at some point. Okay, so here I have taken two functions, function greet and function call me. In function greet, I have passed two parameters, name, callback, and I have written console.log hi place name, and I am invoking the function here. You can see callback. So whatever the parameter argument that you pass here, I am invoking that. Okay, and second function is function call me. Here I have written console.log I'm callback function, and I am invoking the first function greet, and I am passing arguments as Peter and then call me. You can see I have passed second function as a argument to some other function which is greet, and that greet function will invoke me at some point. After that work of that greet is completed, greet will invoke me, right? So that is the purpose of callback. Next, in node also I have taken a simple example. You can see fs.read file, here file name, and this is the callback function guys. So I am passing a callback function to fs.read file method. Whenever the work of that fs.read file is completed, whenever its task is completed, that read file method will invoke me. Okay, so you can see here I've written callback function passed to fs.read file, and 2 will be printed once fs.read file method work is completed. Okay, so this is how callback works in JavaScript. Now let's go to next page. Not this one. Yeah, this is the one. So guys, as we all know, JavaScript is synchronous. That means it can only execute one line of code at a time. Okay, Node does things asynchronously. Node is not synchronous guys. Node does things asynchronously. Asynchronous means more than one process running simultaneously. We will see this in coming pages, but for now, just like a recap, JavaScript is synchronous. It can only execute one line at one point, and Node is asynchronous. Okay, let's go to next page. Yeah, this is the one. So what is this Libuv? So guys, in the last video, we have seen that Node is nothing but it's a combination of C++ program embedded with Google's V8 engine, right? So with node.js, what are we doing here? We are writing server code, right? So writing server code means dealing with low level things, right? Like sending network request, passing data over the network, receiving data from different network, all these things, right? So to perform all these things, Node is not having any capability or any code, and V8 also doesn't have any code, right? To make this happen, Node is using one more dependency which is powerful, which is written using C language, that is called Libuv. Okay, so to make all these things happen asynchronously, Node is using one more dependency called Libuv. Okay, and this Libuv will implement two important features guys. One is event loop, which is the heart of node.js, which we'll talk in some time, and one more is thread pool. Okay, so this is about Libuv, and just for understanding, I have written process and thread here. So process is nothing but it's a program which is currently executing. Thread is nothing but sequence of instructions. In programs, we'll have a sequence of instructions, right? Do this, do that. Those sequence of instructions which are executing is called as thread. Okay, just for the sake of understanding, I have written. This is not important for us. Okay, so let's go to next page. Okay, we are in a new page, and this is where things will get interesting. So let me zoom it. Okay guys, this is how typically it happens. When we get an incoming request, Libuv will pass that request to operating system. Request could be network IO or HTTP request, right? Anything. Once operating system solves that request, it will pass an event. That event will go and sit in the event queue. So this event loop will constantly monitors this event queue if there are any incoming notifications or incoming events, right? When this event queue got any event, then immediately this event loop will pick that event and pass that expected callback to the V8. Okay, and here V8 will execute code synchronously step by step. We all know that once V8 completes its flow of execution, whatever the code that V8 is executing, once that is completed, then only this callback it will pick and it will execute that callback. Okay, so this is how it will happen. Now I want to tell 4 important things about event loop guys. So first thing is, we all know that Node is single threaded. That means whenever node.js application start, a single thread is created, and in that single thread or main thread, these applications start executing, and event loop will also sit in that single thread. Okay, now event loop is a person who will decide what that main thread, what that single thread should do at a given point of time. Okay, so that is the first important thing about event loop. And second thing, we know that JavaScript only handles synchronous things and top level code. So all the synchronous operations and top level code is being executed by JavaScript, and all the asynchronous things are handled by the event loop. Okay, that is the main purpose of event loop. We have seen it in the last page that Libuv performs asynchronous IO operations. So that is what I'm saying here. Event loop will take care of that asynchronous operations. Okay, that is second thing. And third thing is callbacks. So guys, as we have seen, when OS completes its task, it will send an event in this event queue, right? When event loop sees in the event queue that something happened, then event loop immediately pushes this callback to V8 to execute, right? So what happens is that event loop is not just a simple thing, guys. It will have multiple callbacks, it will have multiple phases, and each phase will have multiple callbacks. Okay, let me show you them. If I go to browser and if I type event queue node.js, I got some images. I have taken this one. You can see we have first phase timer. In this, timeout related functions will be there. For example, there is a timeout function which should run after 30 seconds. Then after 30 seconds, that callback will come and sit here, right? Likewise, we have pending calls. Likewise, we have idle ignore and poll. Poll is nothing but along with network IO, we will also have file IO, right? Like reading file from database, reading file from hard disk, writing something to the file in the hard disk, right? When that operation is completed, the callback will associated with that functions will sit here, right? Like this, every phase will have a separate queue, and in that queue callbacks will be there. Now, the purpose of event loop is that event loop will decide which callback it should execute first, which callback it should give priority. Now, fourth thing is, let's go to image. So guys, whenever a new request comes, main thread passes that to the event queue. Event loop picks it and performs necessary action based on the nature of request. So that means request could be normal network IO, nothing but listening to some ports, or network communication between two networks, or simple HTTP request. These are all not CPU intensive, just network request, right? Or request could be time consuming, CPU intensive, like file input output, cryptography, communicating with database, right? So based on the type of request, event loop will decide what it should do with that request. That too asynchronously. Meanwhile, our main thread will continue its work because it's not blocked. Because whenever it's getting new request, it's immediately giving that to the event queue, and from event queue, it's immediately picking up by the event loop. Hence, main thread is not at all blocked. It's always running, right? Now let's see what this event loop will do when it get network IO request. Okay. So for that, we need to go to next page. Okay, guys, this is a simple HTTP request that I have taken. Here we are requiring HTTPS module, and we are sending request to Google, and we are capturing the data, whatever that we are getting. Now, whenever Libuv will seize this request, it will immediately delegates or initiates this above request to the operating system, right? And after issuing, Libuv will wait for the corresponding event, right? Whenever it is sending something to operating system will do that action, and after that action is done, it will send an event. OS will send an event. We have seen the previous image, right? OS will send an event, and once that event will come, this Libuv or event loop will run associated callback, right? And till then, Libuv is free. Event loop is free. It's doing its own work. It's just delegating the request to the operating system. We have seen in the starting page, right, that Libuv handle things at lower level. That is what I meant actually. So it's not doing anything. It's delegating. It's initiating the above request to the operating system. Now, how operating system is handling that request, how OS is taking care of that request, we don't know, right? But eventually, this is what happening. Whenever we are getting a simple network IO, that is taken care, that is handling by operating system. Simple, right? Now the question is how Libuv handles CPU intensive or CPU bound tasks. That is nothing but file input output, which will take a lot of time, like cryptography, hashing, working with databases, like communicating with databases, right? How Libuv handles these kind of tasks. So let's see them. Let me zoom it. Yeah. Okay, guys, here again same thing is happening. First we are getting incoming request, and they are placing on the event queue, and from event queue they are being picked up by event loop, and event loop will decide based on its nature. We already know that, right? Now here the scenario is those requests are very time consuming, very expensive, CPU intensive, right? Then in these scenarios, what event loop will do is that it will take the help of other feature which we already talked, that is called thread pool. So it will offload, it will give that heavy task to this something called thread pool, which contains 4 threads. By default it will contain 4 threads, and we can increase and decrease this thread pool size. Okay, so the concept is event loop will forward the task to this thread pool, and inside thread pool each thread is allocated to that particular task. For example, this thread 1 is working with some communication with database, thread 2 is working with some file system, right? And just like OS, here also whenever thread has completed its work, thread will again notify in the event queue that it's completed its task. Then again event loop, which is continuously checking, which is continuously monitoring this event queue, will see that something has completed. Then event loop, based on the priority, will run that callback associated with that task. Okay, this is how it will work. Now one question will come to us. We have been seeing that node is single threaded, everything is happening in single thread, event loop is also in single thread, but how come externally 4 threads came? How come it is using that something called thread pool, right? The concept is some of the functions that are included inside node that we run will run outside the event loop, outside of that single thread. You got it, right? So all the functions, all the tasks which are CPU intensive, which are time consuming, they will not run inside this main thread. For them, event loop will take help of something called thread pool, which is external threads, and it will work. So that means multiple threads are working for those tasks here. So that is why node is single threaded, program runs on single thread, but for some particular function calls, under the hood, multiple threads will work to achieve that task. Okay, here I've mentioned some of those function calls: crypto.generate key pair, file compressions, file input output, cryptography, hashing and all. Okay, so this is how event loop handles request without blockage, right? Main thread will never block. Why? Because every time main thread is getting some request, it is passing it to the event queue, and again event loop is the person who is taking care of that, right? So that's why main thread is never blocking. And also event loop is not sitting and waiting for the task, right? Event loop is just delegating the request to doing some other task. It's not blocking and waiting for something, right? So it is handling things in a non-blocking way, right? So that is why node.js is good for things like networking request, passing data over network, real-time chat applications, which basically contains data flow. Okay, and not for things which are CPU extensive, which will take a lot of time, which will take a lot of computation power. So I hope you guys understood. So let's do a quick recap, guys. First thing is event loop. Whenever we are getting any incoming request, event loop will take that request and will do necessary action based on nature of that request. Okay, intensive type of request will handle by thread pool. Simple network IO request will be handled by operating system, right? In that way, main thread is never busy. Okay, if you still have any questions, please ask in the comment sections. If you found this video useful, please consider subscribing, guys. Thank you.